This is AP Calculus 4.3, rates of change in applied context other than motion. A store is having a 12-hour sale. The total number of shoppers entering the store T hours after the sale begins is modeled by the function E of T equals 0.3 T to the fourth minus 14T cubed plus 110 T squared. For the values of t being between 0 and 12. That's 0 and 12 hours. So 0 is when this problem starts, when the sale starts, and 12 is the time when the sale ends, because they say up here it's a 12-hour sale. At what rate are shoppers entering the store at t equals 5 hours? So they're asking us at what rate are shoppers entering the store. If they want this to be converted to a rate, if you think about it, rate of change is the derivative of the given function. So I'm going to find e prime of t, and once I find e prime of t, I want to plug in 5 to get e prime of 5. The rate shoppers are entering the store at time 5 hours. So if I just take the derivative, I'm going to have 1.2 t cubed minus 42t squared plus 220t. And then if I plug 5 into this function, and you can use a calculator for that, you don't have to do that in your head, that is 200 shoppers for our rate per hour. The E of t represented the number of shoppers, and the rate means it's the number of shoppers per hour. The rate of consumption of liquid chocolate in Switzerland is given by R of t equals CE to the KT, where R is measured in millions of gallons per year and T is measured in years from the beginning of 1990. So at time 0, the beginning of this problem starts at 1990. And the consumption rate doubles every 9 years. So it doubles every 9 years. And the consumption rate at the beginning of 1990 was 2 million gallons per year. So what they're telling us here is the beginning is 1990. So that's your time 0, t equals 0. So they've really given us an ordered pair here. When time is 0, the amount of consumption is 2 million gallons per year. So our initial amount is 0, 2. At time 0, when the problem starts, we're consuming 2 million gallons per year. Now, they tell us in the problem that this amount doubles every 9 years. And then they're asking us to find C and K. Well, the good news here is they gave us C. C is the initial amount. Remember, when you're talking about an exponential growth problem, this is the standard formula for the exponential growth model, and C is always your initial amount at the beginning of the problem. They're telling us here that C is 2. So we found C just by reading the problem. C is 2, and that's million gallons per year. And if we want to figure out our K value, then we can plug into this formula. Now, we know that the initial value C is 2. E is our exponential number. K is what we're trying to find. Now, we know that if we start with 2, it takes 9 years to double. So if we started with 2 million gallons per year, to double that, that would be 4. Double 2 million gallons per year is 4. And they tell us in the reading that that takes 9 years. So our T value for this to happen is 9 years. So I'm going to put 9 there. And then I'm just going to solve. I'm going to divide by 2. That's equal to e to the 9k. How do you get rid of an e? You put a natural log in front. Remember, a natural log undoes an e value. So we have natural log of 2 equals 9k. So that means our k value is natural log of 2 divided by 9. So remember, in the growth and decay model, that's something that we covered, or you should have covered, in your Algebra 2 course and in your pre-calculus course. So this problem right here really should be all review, nothing new there. The water temperature in a tub is decreasing. the twice differentiable function w, where w of t is measured in degrees Fahrenheit, so there's our unit of measure, and t is in minutes. The water is cooling for 30 minutes, beginning at t equals 0. Select values for w of t are shown in the table. Estimate w prime of 15 and show the consumption. Use the correct units. Interpret the meaning of your answer in the context of this problem. So if they're asking us to find w prime of 15, we know that w prime is the rate of change. It's the derivative, a rate of change. Now in this problem they have not given us an equation to use, so we know that if we're going to find w prime of 15, we have to use the difference quotient. Now I see here our t value they want us to use is 15. 15 is between 10 and 20. So I'm going to use these two ordered pairs to get our w prime of 15. So I know that w prime of 15 is going to be equal to the difference quotient of w of 20 minus w of 10 over 20 minus 10. And if I do that math, w prime of 15, w of 20 is 79 from the chart. W of 10 is 90 from the chart. 20 minus 10 is 10. So w prime of 15 would be negative 11 over 10 degrees Fahrenheit per minute. And they said, estimate w prime of 15, show the computation, which we did right here. Use the correct units, we did right here, and interpret the meaning of your answer in the context of this problem. Okay, so what they want us to interpret, this is kind of goes back to our section 4.1 where we're interpreting the data. At time 15 minutes, the temperature of the water in the tub is decreasing, because it's negative, it's decreasing. So the temperature of the water in the tub is decreasing at a rate of 11 over 10 degrees Fahrenheit per minute. That would be a good interpretation of what this problem is asking you to do. So they have, this actually puts into use in a word problem what we did in section 4.1.